Something unbelievable is happening in Florida right now as SpaceX builds the Gigabay, a massive structure so large that even NASA engineers are stunned by its scale. From a distance, the site looks like a normal construction zone, but each new steel frame rising from the ground reveals an industrial system designed to produce starships at a speed never seen in the history of spaceflight. As the ambition grows, the pressure around the project rises. Yet Elon Musk believes the Gigabay will open a new era and turn Florida into the biggest rocket production hub on the planet. This video will take you closer to the Gigabay and uncover the breakthroughs that are making NASA and other space agencies stop and pay attention. The story of the Gigabay begins with a simple problem that grew too big for the old way of building rockets. SpaceX realized that producing one Starship at a time would never be enough for the goals they were chasing, because missions to the Moon and plans for Mars need a constant flow of new vehicles, not a slow schedule that only delivers a few prototypes each year. The traditional method of assembling rockets piece by piece in open yards or small hangars could not support that vision, so the company needed a place where speed, scale, and efficiency could finally meet. That need led to the creation of the Gigabay, a factory built to match the dreams behind the Starship program. The Gigabay rises in Florida like a steel landmark that announces a new era of aerospace manufacturing. It reaches about 380 feet into the sky, a height equal to many skyscrapers, and its interior holds more than 46 million cubic feet of open space that stretches upward like a tall industrial cathedral. This vast interior was designed so workers can assemble the largest rocket ever built without squeezing through narrow spaces or moving parts outside where weather can slow everything down. The purpose of the Gigabay is clear because every beam and column supports one mission, which is to turn Starship production into a continuous and organized process. What makes this factory different is not just its size, but the system inside it, which looks more like a modern aircraft plant than anything the space industry has seen before. The building contains 24 work cells, and each one operates as a complete production zone where teams can weld hull sections, fit internal structures, install engines, or prepare electronics. These work cells let SpaceX build up to 24 stages at once, a method that transforms rocket construction from a slow sequence into a steady flow. This approach has never been used at this scale in spaceflight because rockets were always treated as special machines made by hand rather than durable products built for repeated missions. When 24 starships or boosters can be in progress at the same time, the entire rhythm of the industry changes. To see how different this is, you can compare the Gigabay with NASA's Vehicle Assembly Building, the legendary structure that held Saturn rockets before the Apollo missions. The VAB was designed for single vehicle assembly, which meant the next rocket could not move forward until the current one was complete. The Gigabay reverses that philosophy because it supports movement on every level, with crane paths, tall sections, and wide corridors built for non-stop production. This factory also keeps nearly every step indoors, which protects delicate parts from wind, heat, and rain that often slowed work at Starbase in Texas. By controlling temperature and weather exposure, the teams can maintain a consistent pace day and night, a benefit that becomes essential when planning long chains of manufacturing. The Gigabay lets SpaceX prepare stainless steel rings, dome sections, and full skins all in one place, and that stability helps engineers design parts that fit into a repeated cycle instead of a one-time build. This move toward industrial certainty is what gives SpaceX the ability to think beyond prototypes and toward fleets of starships ready for future missions. Every new piece added to the Gigabay brings it closer to the moment when rockets can be produced like aircraft, and when that happens, the entire field of spaceflight will shift in response. What kind of vehicle requires a factory of this scale? The next part of this story explores the Starship itself and explains why only a building like the Gigabay can handle a machine of that size. The Starship stands at the center of SpaceX's ambitions because it is the largest and strongest launch system ever created by human hands. This two-stage vehicle combines the Super Heavy booster as the first stage and the Starship spacecraft as the second stage, and together they form a machine designed to carry more mass and reach deeper destinations than any rocket in history. The scale of this system becomes clear when you look at its height, which rises to nearly 400 feet, a figure that places it above the legendary Saturn V that sent astronauts to the moon. That difference in size reflects a difference in purpose, because Starship is not made for a single mission, but for repeated journeys that can support heavy cargo, large crews, and long-distance exploration. The power behind Starship begins with the Super Heavy booster, a giant structure filled with 33 Raptor engines that burn methane and oxygen to produce extreme levels of thrust. These engines fire together to lift the entire vehicle off the ground, and the combined force gives Starship more raw power than any launch system built before. The upper stage holds 6 more Raptor engines, which help the spacecraft push through space after separating from the booster, and this arrangement allows Starship to complete missions that once required multiple rockets. The design of the vehicle shows a clear goal, which is to build something strong enough to support the moon and flexible enough to reach Mars. One of the most important features of Starship is its plan for full reuse, because both stages are meant to return and fly again after each mission. The Super Heavy booster is designed to come back to its launch tower, where the Chopsticks will catch it and place it on the mount for another flight, while the upper stage will re-enter Earth's atmosphere and land safely for refurbishment. This approach lowers costs by reducing the need for new parts, and it also opens the door to frequent launches, which are necessary for building outposts on other worlds. NASA recognized the potential of this system when it selected Starship to land astronauts on the moon during the Artemis program, and that decision shows how important this vehicle is to the future of human exploration. The spacecraft offers enough internal space to carry large amounts of scientific equipment, supplies, and lunar hardware, and it can support crews for longer periods than earlier spacecraft. SpaceX looks far beyond the moon when planning Starship, because Elon Musk views this vehicle as the first step toward building a human settlement on Mars. The stainless steel structure of Starship can withstand the heat of atmospheric entry, and its large volume allows it to carry tools, habitat pieces, and cargo needed for long-term survival on another planet. To support that vision, SpaceX needs a production system capable of building many Starships quickly, a launch site strong enough to handle the mass of the booster, and heavy machinery like the LR-13000 to move giant structures into place. These demands explain why Florida has become the main hub for the program, because it provides the scale and conditions required for this next phase of development. The Starship is not just a vehicle, but a roadmap to a future where space travel becomes routine rather than rare. Yet this future depends on how well SpaceX can apply what it learned in Texas and turn it into a fully optimized system in Florida. The next part of this story explores why Florida is considered the perfected version of Starbase and why those improvements matter for the path ahead. Florida became the next stage of SpaceX's development because the company needed a place that could fix the problems they faced in Texas while pushing production to a new level. Boca Chica was the birthplace of Starship, and it gave SpaceX the freedom to experiment, fail, adjust, and learn without heavy restrictions. The site allowed early prototypes to rise into the sky, explode, and teach engineers what worked and what did not, which helped the team understand how giant stainless steel rockets behave under real stress. This learning phase shaped the future of the program, but the environment in Texas often slowed everything down in ways that SpaceX could not control. Strong winds forced engineers to pause outdoor assembly, heavy storms pushed schedules back, and the intense heat limited how long teams could work safely. Transporting large rocket sections across narrow local roads also caused delays, because every move required shutdowns, escorts, and careful coordination. SpaceX realized that these conditions made it difficult to scale up production, since building one rocket at a time was possible, but building many rockets at once demanded something far more stable. Florida offered the solution by giving SpaceX the space, weather conditions, and industrial layout needed for non-stop work inside a completely enclosed environment. The Gigabay acts like a shield that protects every step of assembly from the outside world, which means engineers can work day and night without worrying about storms or wind interruptions. The building supports a controlled workflow, where cranes, transport lanes, and supply areas are arranged in a straight and efficient pattern instead of being scattered across open fields. This layout fixes the movement issues that slowed Texas, because large rocket parts now travel along planned routes that were designed from the beginning to handle oversized loads. The entire facility feels like a small industrial city, with constant deliveries of steel rings, engine parts, and cryogenic systems moving through doors built for this exact purpose. These improvements show how Florida has evolved from a simple launch site into a fully optimized production center that comes from years of lessons learned at Starbase. SpaceX no longer tests ideas in the open, because the company now builds inside a system designed for high output, predictable schedules, and long-term goals. Every piece of infrastructure reflects what the engineers discovered through failure, which makes Florida not just bigger, but smarter than the first site in Texas. This shift brings the company closer to a world where Starship production looks more like a factory line than a traditional rocket program, and that difference could change the future of space travel. SpaceX is known for a way of working that focuses on building, testing, failing, and fixing faster than any space organization has ever attempted. This method is called the SpaceX pace, and it allows the company to learn from mistakes quickly instead of waiting years for a perfect design. Engineers often create a prototype, launch it, study the results, and improve it right away, which means every setback becomes a lesson that sharpens the next version. NASA usually needs long approval processes before making changes, so a review might take months, while SpaceX often finishes similar steps within weeks. This difference in speed becomes even more dramatic when the company moves from open fields to a controlled industrial environment like the Gigabay. The huge building creates the perfect space for high-volume production, because teams can work on multiple sections at the same time rather than waiting for one part to finish before starting another. An airplane factory uses this method to build dozens of wings, engines, and cabins in parallel, and SpaceX is applying the same idea to Starship. Every work cell focuses on a single job, and when all 24 are active, there is a constant flow of progress that looks more like car manufacturing than rocket construction. This approach helps reduce downtime because the company does not pause production for weather or outside interruptions. The controlled environment also supports rapid testing, since engineers can modify a design, install it in the next build, and watch how it performs within days. The faster the company repeats this cycle, the more detailed their understanding becomes, which increases reliability over time. This system creates a rhythm where each new version of Starship is stronger than the last because improvements are added step by step, instead of waiting for one huge upgrade. The Gigabay acts as an amplifier for this rhythm because it gives SpaceX the space, equipment, and organization needed to maintain continuous momentum. When teams work under the same roof, communication becomes easier and problems can be solved in minutes instead of hours. Supplies move directly from storage to assembly lines, which keeps everything smooth and predictable, helping the whole system run like an engine that never stops. This pace is the reason many people say SpaceX feels more like a technology company than a traditional aerospace contractor. The speed does not just create rockets faster, it also changes the expectations of what is possible when innovation becomes a daily routine instead of a long-term promise. So if the SpaceX pace is rewriting how rockets are built, what happens when this speed is applied to the place where humanity first left Earth? The next part explores how SpaceX is rebuilding launchpad 39A and turning a historic site into a new stage for the Starship era. Launchpad 39A is one of the most symbolic places in space history, and SpaceX is now rebuilding it to handle the power of Starship. This was the site where astronauts climbed into Apollo rockets before traveling to the moon, and it later carried the space shuttle for more than 30 years. These missions pushed the limits of engineering, yet the forces created by Starship go far beyond anything this pad has ever experienced. The Super Heavy booster produces more thrust at liftoff than any rocket that has launched from Earth, so almost every part of 39A needs to be reimagined. The flame trench must be rebuilt from the ground up because it needs to survive a massive stream of exhaust moving at near supersonic speed. The 4 giant support legs now hold shock systems and cryogenic lines that feed methane, liquid oxygen, and nitrogen into the Starship stack. A new tank farm is rising beside the pad to store fuel for missions that are longer and heavier than anything SpaceX has launched before. These upgrades are not simple replacements, because each change must meet the demands of a vehicle that stands nearly 400 feet tall. The work becomes even more impressive when you consider that Falcon 9 launches continue only a short distance away, so the team must build, coordinate, and operate all at once. This level of logistics is rare in the aerospace world, since few companies work on active pads while constructing entirely new structures beside them. To make the process smoother, SpaceX brought in the LR-13000, which is the strongest crawler crane on the planet. The crane can lift more than 3,000 tons, which gives engineers the confidence to move the heavy launch mount and align steel structures with extreme precision. Florida only needs this one machine to complete tasks that previously required 2 cranes working together in Texas, reducing risk and speeding up the entire project. These improvements reveal how SpaceX is turning a historic launch site into a modern stage for future deep space missions. So if the pad itself is becoming stronger and more advanced, how will SpaceX handle the challenge of catching and reusing a rocket this massive? The next part explains how the Chopstick system is being upgraded to match the power of Starship. The Chopstick system is one of the boldest ideas SpaceX has ever tried, and Florida is building a stronger version to match the power of Starship. These giant arms sit on the launch tower, and they move along rails to lift the booster, hold it in position, and guide it during stacking. The system works with a large carriage that carries the weight of the arms and keeps every movement controlled, while reinforced pins lock the booster in place whenever engineers need perfect alignment. This design is the heart of SpaceX's plan for fast reuse, because the booster must return to the tower and land between the chopsticks after every mission. The idea sounds impossible at first, since the booster drops from the sky at extreme speed, yet SpaceX believes the tower can guide it safely with sensors, cameras, and real-time adjustments. The Florida version of the system is larger and more stable than the one in Texas, because Starship flights from 39A will carry heavier payloads and more demanding missions. Engineers increased the strength of the rails, improved the frame of the carriage, and redesigned the arms so they can hold greater loads without shaking. This upgrade is important because the booster must be lifted, stacked, and lowered with accuracy that leaves almost no room for error. A small shift can cause delays and force teams to reset the alignment, so SpaceX is building a system that moves smoothly even when the wind is strong. The company wants the booster ready for its next flight only hours after landing, which means the chopsticks must perform the entire process faster than any traditional crane. These changes are part of SpaceX's long-term goal to treat rockets like airplanes by reducing the time between launches and keeping every part in rotation. The faster the system works, the sooner Starship can complete the missions needed for lunar landings, deep space cargo runs, and future trips to Mars. Florida is becoming the testing ground for this new generation of high-speed reuse, and each improvement brings the system closer to real flight operations. The Sea Bridge is one of SpaceX's most strategic moves because it lets the company send Starship hardware from Texas to Florida long before Gigabay is fully built. This system works like a supply line across the Gulf Coast, and it keeps the Florida site active with new parts, test sections, and support structures arriving by ship. Large transport vessels carry full Starship sections along the route from Boca Chica to Cape Canaveral, and even though the trip takes days, it is still faster than waiting for the new factory to finish construction. Each shipment brings Florida closer to its first Starship launch, and this shows how SpaceX values time because every saved month gives them an early advantage. Engineers in Texas continue building prototypes, and instead of storing unfinished stages, SpaceX sends them straight to Florida, where teams can use them immediately. These parts help workers practice tower operations, align the chopsticks, test the launch mount, and rehearse stacking procedures long before a real mission takes place. This flow of hardware keeps both sites synchronized, which is important since Starship will eventually operate from multiple locations around the country. The Sea Bridge also prevents Florida from falling behind during long construction phases, and it reduces pressure on Texas by keeping production lines moving without delays. Some ship sections are not meant for flight, yet they are valuable because they allow engineers to test cranes, check measurements, and train teams under real conditions. Other pieces are early prototypes that help builders understand how the new systems react under weight and during heavy lifting. Every delivery strengthens the Florida site because each part fits into a larger plan that continues even while Gigabay is still rising. SpaceX used this strategy in past programs with Falcon 9 and Dragon, and it proved that moving hardware early can shorten timelines dramatically. If the Sea Bridge helps build the future, what past victories gave SpaceX the confidence to attempt something this massive? The next part reveals how their greatest successes built the foundation for Starship's new era. SpaceX can attempt a project as massive as Gigabay because every major success they achieved over the past decade proved that the company can handle challenges once seen as impossible. Falcon 9 became the first clear sign of this confidence, since it was the world's first orbital rocket that could launch, land, and fly again safely. The rocket built a record of more than 300 successful missions, and this reliability forced the entire space industry to rethink how rockets should be designed. The cost of launching payloads dropped from hundreds of millions to a fraction of the old price, and this shift changed the economic model for every government and private operator. The landing of boosters also became a cultural milestone because many experts once believed that a controlled return to the pad or a drone ship was unrealistic. These returning boosters now form the backbone of SpaceX operations, and their success proved that reusability is not only possible but practical. Crew Dragon strengthened this foundation when it carried astronauts to the International Space Station as the first commercial spacecraft to achieve that mission. NASA and ESA now rely on Dragon for regular crew and cargo flights, and this trust shows SpaceX has reached the highest safety and performance standards. This achievement helped SpaceX win the Artemis contract, which will return humans to the lunar surface using a modified Starship. Starlink added another layer to the company's reputation since SpaceX launched thousands of satellites using its own rockets to create the largest communication network in orbit. The high launch rate required to build Starlink showed SpaceX could operate at a speed unmatched by any national agency. The company now performs more than 90 launches a year, and this rate proves they can manage a complete cycle of production, launch, and reuse similar to a modern factory. These victories form the base that allows SpaceX to imagine Gigabay as the next step in expanding its capabilities. Gigabay is more than just a factory. It is the embodiment of the will, belief, and desire to reshape the future of space travel. Each steel beam assembled in Florida carries a new philosophy, transforming spaceflight from an expensive experimental field into a dynamic and sustainable industry. So how many rockets will Gigabay produce each year? And what new horizons will those spacecraft take humanity to? All eyes are on Florida, waiting for the answers to be revealed when this great project is completed.